Hello everyone, we are from Group 7, Section 2, SEEE3533 Communication Principle. We are going to present our group assignment, which is case study project for Mission 4. This video will be presented by me, Muhammad Fidas bin Muhammad Noor, Wan Akmal Nazirah binti Wan Ubaidillah and Sharif Faisal. Make sure you watch the video until the end to understand a bit about amplitude modulation, angle modulation, and radio digital modulation to answer the Mission 4 and the question. To play Mission 4, we need a bit of basic knowledge about modulation. What is amplitude modulation? Amplitude modulation is change in amplitude of the carrier signal according to the modulating signal. Hence, the amplitude modulated signal VAMT will be generated. After we modulate the signal, amplitude modulated signal is generated. So how to convert it back to modulating signal is by using the amplitude demodulation. Amplitude demodulation is a process of converting the modulated signal back to the modulating signal VMT. We use envelope detector to modulate the signal. The signal will pass through the diode, low pass filter, and the DC component blocker. To produce the frequency modulation, we make sure the modulating signal VM go through integrator and PM modulator, and then the general equation of VFM is generated. Same goes to VPM. To generate the phase modulation, we will pass the modulating signal through the differentiator and the FM modulator, which is frequency modulation modulator. For the phase demodulation and frequency modulation, we can use the PM demodulator to demodulate VFM, and we can use the FM demodulator to demodulate VPMT. Now for bitrate and baud rate, the difference between bitrate and baud rate is bitrate is number of bits transmitted per second, while baud rate is the number of symbol transmitted per second.
Assalamualaikum warahmatullahi wabarakatuh and greetings. My name is Wan Akmal Nazirah binti Wan Ubaidillah from Group 7, Section 2 for the course Communication Principles. In this video, I will explain about ASK and FSK so that viewers can get a better understanding of this topic. Amplitude shift keying, ASK, is a type of amplitude modulation which represents the binary data in the form of variations in the amplitude of a signal. As shown in the slides is a diagram for ASK modulated waveform along with its input. Any modulated signal has a high frequency carrier. The binary signal when ASK is modulated gives a zero value for low input and gives the carrier output for high input. On the other hand, frequency shift keying FSK is the digital modulation technique in which the frequency of the carrier signal varies according to the discrete digital changes. FSK is a scheme of frequency modulation. As shown in the slides, is the diagram for FSK modulated waveform along with its input. The output of a FSK modulated wave is high in frequency for a binary high input and is low in frequency for a binary low input. The binary ones and zeros are called marked and space frequencies. The difference between ASK and FSK is that first, ASK is the digital modulation technique in which amplitude of the RF carrier is varied in accordance with baseband digital input signal. FSK is also a digital modulation technique in which frequency of the RF carrier is varied in accordance with baseband digital input. Moreover, in ASK, binary 1 will be represented by carrier signal with some amplitude, while binary 0 will be represented by carrier of zero amplitude. In FSK, binary 1 and 0 is represented by two different carrier frequencies. For example, binary 1 is represented by high frequency F1 and binary 0 is represented by low frequency F2. So, is ASK or FSK better? Yes, FSK is better than ASK in the cases that the carrier has a constant amplitude and hence are used in the communication systems where security reasons are considered. but this does not always apply due to it being faded and less as over long-distance communication. This is because its SNR decreases and hence produces low quality of signals. That's why then the PSK, BPSK, QPSK, DPSK are introduced to overlook this disadvantage too. We are going to look into this topic next slide.
Greetings, my name is Sharik Faisal and I will be explaining the phase shift keying modulation technique, which basically modulates or modifies the carrier signal's phase, the sine and cosine function of it. And so it's different from PM as in the phase modulation because it's a digital method. So there's a lot of applications of this technique, as in, there's wireless LANs or biometric connections, Bluetooth, RFID, etc. So there's two common PSK methods: the binary phase keying method and the phase shift keying method, and the quadrature phase shift keying method. So for the first type, which is the binary phase shift keying, BPSK, is essentially, because as the name suggests, binary, it operates in zeros and ones. And the biggest giveaway for this one, if you look at the constellation diagram on the right, you can see that the 1 and the 0 are in 180 degrees phase difference from each other. So by looking at the waveform on the left, you can see that the signal is almost flipped every time because of that difference. And so the second type of phase shift keying method, or the quad phase shift keying method, QPSK, essentially operates in 4 carrier signal alterations, so in 4 quadrants from a 360-degree diagram. So if you look at the diagram on the right, where you can see the signal waveform, this operates with 2 bits of information, so zeros and ones. So you can have 0 0 and then 1 0, etc., or 0 1. And if you were to look at the quadrant at 0, it would be at 0 0, and then it would go to at 45, it would be at 0 0, and then at 135 degrees angle it will be to 0 1. So this isn't a linear progression, but this is normally operated by the gray code. So we use that method to go around the waveform for this one. And finally, we have the quadrature amplitude modulation, or the QAM. So this technique essentially uses 2 AM signals and combines them into a single one, and this allows for a greater bandwidth, and it has multiple applications. For example, Wi-Fi 5 and I believe Wi-Fi 6 use higher versions of this technique. And if you look at the constellation diagram, you can see that all of the signals are in 90 degrees phase difference, and they're aligned together in pairs of 4 on each quadrant. And there's higher variance of this. This is a 16 QAM signal, but there's more like 64. And the problem with having more is that if there's a lot of them and they're close to each other, there could be more noise or there could be more errors. So there's that for the benefit, pros and cons.
To register for the Ericsson Tech Traveler, simply put your email and then re-enter email address, select country, tick the box and continue.